Hello, my name is Andrejs Olins and I will guide you through some of the things that we have found out that people are coming to bootcamp are lacking. And today our theme and our topic is database. So what is the database? Database is some kind of storage of the information. And right now, de facto, database is a synonym of database management system. So database itself are just files, but data management systems are also handling some kind of request to that database and handling users and whatsoever. So the next thing, what is the database? Database is an application whose main purpose is to store and serve data, serve information. So for example, some kind of different applications might need to use a lot of CPU power because they make some kind of interesting calculations, but the database is just storing the information on some devices and then it's serving those back. About 90% of databases now are using tables and rows of those tables to store information. There are different type of things, but we will not talk about because there are not much of those databases at the market right now. Most of the databases are using structured query language as language how you interact with those data. And we will grasp a couple of the main features of that language later on. There are a couple of differences between regular application and the database. So if application can go down, that the database basically should not. And this is because we are using database as place where we store the state of our application. And if the database goes down, then it's going to be a lot of trouble. Application can lose its state, but the database should not. If the application can lose its state, then we can restore that state from database. But if the database is losing the state, then we're once again in a big trouble. Application can have a lot of complex logic in it, but the database should not. As I've previously said, main purpose of the database is just to store and serve data. Application might throw an error, but the database should not. Most probably all of you guys have seen some kind of errors either in browsers like 500 error or 404 error. That means that there's something wrong with either your request or with the state of some kind of internet server. If some kind of portal throws this error, we can handle that, but if the database throws some kind of error, then it means that we have to deal with a serious trouble and most probably some kind of backups. As we're mostly going to think about databases that uses tables, therefore you can think of a table that's something that is storing similar type of information. You can think about a table as a sheet of paper where there are different type of records in it, and the records are objects of the information. And you can think about the records as rows in this particular table. So you can just add another row or like change some kind of information in that row or even delete the row. And the records are containing of the columns, and the columns have the same data type. For example, one data type might be an integer, some kind of digit, number of flags, number of kilos, and another type might be some kind of character values like a name or a surname or address. And right now we're going to cover main SQL operations. There's an acronym for that. It's CRUD, C-R-U-D, for create, read, update and delete, and we're going to cover all of those. So the first thing is the insert statement. It is shown here. The main point of the insert statement is that you're inserting some kind of values into the table, and you can think of it as just creating yet another row and just gluing it with a scotch tape onto your table. The next statement is the update statement, and it is written here. And you can think of it as if you just have the character pen and you just come to this table and you erase the data that is wrong and filling the data that should be fine. The next statement is a delete statement, and you can think of it as if you're just coming to the table with the scissors and cutting away some kind of records that are no longer necessary. And the next statement is a read statement that is written here. Starts with select keyword, and what it does, it creates a copy of the data from the table that matches your criteria. As we come to some kind of dependencies, there's definitely one thing that all of you are going to face, and this is called the database driver. This is the piece of code packed into a library that handles application to database connectivity and communication. And there's going to be a different piece of code for each language and for each new database. There are a bunch of databases, there are a bunch of languages, and if you want to connect, for example, Java application language with MySQL database, you're going to need to have a driver between those. And if you want to have yet another connection between MySQL database and, for example, C#, then once again you're going to need to have yet another driver to handle this. And there's a notion of ACID. This is yet another acronym that stands for atomicity, consistency, isolation, and durability. And these are the things that every database should meet. And the first thing is the atomicity. For example, we are not usually working with a database with a single like insert or delete statements. We're working with that in a packs of those statements that call transactions. For example, you might need to insert one row here and delete another row from here and modify another row from here. And the things that atomicity stands for, that we're packing those three different interactions into a transaction, and transaction will either succeed as a whole or it will not succeed as a whole. There might not be such a situation that the first and the third statements will gonna endure and the second one will fail. The next thing is consistency, and it means that all the transactions that, for example, database is taking upon it will bring this particular database from valid state to a valid state. There will be no such transactions that will violate the state. For example, if you're trying to make some kind of rearrangement in your house, this means that from the start there will be your house will be in a valid state, and after, for example, your refurbishment will end, it should bring your home once again into a valid state where you can live in. There should not be some kind of situation when your refurbishment has ended or construction works and you have left with no window, for example. This is meant by consistency. And the next thing is the isolation. This means that despite the fact that transactions are coming in a random manner, their result should be equal. Either they're going to be executed concurrently or sequentially. This is very interesting and important point, because mostly there is one database that is storing multiple applications that are trying to access data or modify data at the same time. And the database management system should ensure that nothing is broken and the state is valid. And the last thing, but not least, is the durability. As we've previously have discussed, that the application can go down, can throw errors, but the database should not. And all the transactions that database says they are committed, they are fine, they are stored, they should be there even if there's some kind of breakdown in whatever database state. So in this case, if the transaction is committed, it means that if we turn the server off at this particular moment, they will stay there. And this brings us to the end of this topic devoted to the databases. My name is Andrejs Olins, and I will guide you further on.